to remember that with vehicle electronics or electronics in vehicles, back in the day, back in the early 90s, there used to be basically two grades of components, electronic components. One was domestic commercial, which is fell under the same umbrella, and the other grade of electronic components was military, space, aerospace, space components, military, one and the same. So two basic categories of electronic components. And there are trade-offs on both. With domestic commercial components, they tend to be a little bit more performance oriented at the price of a temperature and robustness and things like that. They didn't handle temperature very well, large variances in temperature very well, and they weren't so robust. Whereas military and aerospace components will tolerate a high degree of temperatures. Now wind the clock forward 30 years and there's a lot more involved in electronics than what there used to be 30 years ago. I think the grades that are available now are domestic grade, commercial. I think they're more or less separated, domestic commercial. You have automotive grade electronic components, industrial grade components, military grade components, and I think aerospace grade components. So they split them all up into different areas, and of course you have a lot more electronic componentry coming out of the market, or different grades of electronic. As you move up the scale of the grades of electronic components, they become more robust and more temperature tolerant. Some will operate under military grade, and aerospace componentry will operate under higher temperatures than domestic and commercial grade components. Automotive and industrial design for those industries. In vehicles, in ECUs, in vehicle ECUs, the temperatures can get quite high, and they can tolerate those temperatures. DC converters, they're more than likely, from what I've heard, made from domestic or commercial grade components. They won't tolerate those temperatures very well. And similar temperatures inside canopies can get very hot too inside. If you can imagine, you've parked your truck at a shopping centre, you're going to do a bit of shopping, you're there for an hour or two. The sun's blaring on your aluminium canopy, and it's reached 60-70 degrees, and these DC converters only tolerate up to 50-55 degrees Celsius. And your inside cabin temperatures, or your canopy temperatures, are about 60-70 degrees. You're slowly killing those components inside your DC converters. Not a really good idea. Put them on the outside, allow them to vent if you can, or have very good ventilation in your canopy, one or the other. I mean really good ventilation, because you want to drop those temperatures down in the canopy below 50 if you can. Very important. Another thing to consider is that when you buy electronic equipment, they're tested at standard temperatures. Standard temperature, international temperatures, are 21 degrees Celsius. So if you have a DC-DC converter, or whatever it is, a DC-DC converter, whatever it is, they're tested at 20 amps at 21 degrees Celsius, 40 amps at 21 degrees Celsius. Once those temperatures start to rise, say to 40 degrees or 50 degrees inside the canopy, those charge rates at say 20 amps no longer applies. It might be 15 or 10 amps, or it might be 30, 20 amps. So if you're drawing a lot of power through those converters, DC converters or whatever that you might have in there, you're charging your batteries, and because it's been degraded to an extent because external temperatures are rising, you may be killing off those little suckers pretty quickly. So keep that in mind, that these things are tested at standard temperatures. 21 degrees is usually the standard temperatures are tested at. And with electronic components, with the individual, or what we would call discrete electronic components, as the temperature rises, ambient temperature rises, their efficiency levels or their capabilities are affected. So just bear that in mind when you keep things inside the canopy and you have the ambient temperatures rising. Always err on the plus side. Don't take things to the limits, because as temperature rise, the efficiency of the charge rate of those DC-DC chargers will drop.